Class, we seem to experience some technical difficulties, so we're going to do this as part 2 of this lesson, simply because there was an error. I have no idea what happened, but anyway, we're going to just restart at example 2 here from the lesson 3.5. Again, ladies and gentlemen, we've read this question and this is in standard form. So what do we know about the baseball? We know that the initial height of the ball is 0.5 meters, okay? And I believe we got to the point where we drew a diagram. So we know the ball is going to be hit or flight or whatever, thrown, whatever we're going to say, at 0.5 meters. That's where it starts. It's going to go up in the air, reach a maximum height, and come back down, okay? Instead of X and Y, we have T and H. Okay, so ideally the maximum height is there and when it occurs, which is at the vertex. But what we're not looking for this time is how long it will take for the ball to hit the ground. So we're no longer interested in what's called the vertex or the maximum height. We're actually interested in the x-intercept or the solution or the root. Some people call it the zero. Okay. And if you wanted to find the other symmetry point, ladies and gentlemen, the opposite is here. But that's going to be negative time, so we're not going to count this one. And I believe we did that already. Okay, just to double check what video parts covered. So not count this one. Okay, so basically, ladies and gentlemen, what do we know about where this x-intercept is? We have to let the height equal 0. So in order to do that, we let h at t equals 0. So what does that mean? 0 equals negative 5.2 t squared plus 3t plus 0.5. Now to solve or to find the variables, you can either factor or use quadratic formula. Looking at this expression, folks, it has decimals in it already, so immediately I'm going to use the quadratic formula. So we're going to sub it in. So it's going to be t equals negative 3 plus or minus the square root of 3 squared minus 4 times negative 5.2 times 0.5, and that's all divided by, ladies and gentlemen, 2 times negative 5.2. Okay, use your calculators and sub that in. Apologize, some of the answers still there. Okay, from before, so t, simplify that, folks. You should get negative 3 plus or minus 19.4 divided by negative 10.4. All right. Then, ladies and gentlemen, we break it down into its two cases. So either t equals negative 3 plus root 19.4, all divided by negative 10.4, or your other option, t equals negative 3 minus root 19.4, all divided by negative 10.4. Okay, so what we're going to do is we are going to then plug these values into our calculator. So you plug the first value in and you should get t equals negative 0.14 s. Okay, and the second value, sorry guys, my second value, ladies and gentlemen, when I plug that in, is t equals 0.71 seconds. Looking at our values, folks, we can reflect back on our diagram. Okay, this negative one is that initial one that we're not looking for, so we're going to discount that one and not include it. So the one value we're looking for is this one. So then therefore it took 0.71 seconds for the ball to hit the ground. All right. So again, we use the quadratic formula to solve and find the time it took for the ball to hit the ground. So it must have been a grounder or something since the time was short. Okay, let's take a look at our last example, ladies and gentlemen. It is example 3. A rectangle has an area of 400 meters squared. This is opposite of what we're usually used to seeing with our fencing questions. Okay, so in fact, the area is given this time. Okay, one side is going to be 5 meters longer than the other. What are the dimensions of the rectangle? So like before, we're going to let W be our width, Okay, and if one side is 5 meters longer, let's let our length be W plus 5. Okay, and in this case, we know the area, so area equals 400 meters squared. The question is, what are the dimensions of this rectangle? Well, what do we know? Area equals the width times the length, which is W plus 5. If we expand that, we know that's W squared plus 5W, but we can also substitute in our area, which is 400. Okay? In order to figure out our dimensions, we need to move all our values to one side. So 0 equals W squared plus 5W minus 400. All right. Ladies and gentlemen, you could spend a minute or two trying to factor this, trying to see, hey, my product's negative 400 and my sum is 5. Spend a couple minutes seeing if you can factor. If you can't factor it, then let's just go to the quadratic formula. So in this case, our variable is W we're solving for. So use the quad formula. W equals negative 5 plus or minus 5 squared minus 4 times 1 times negative 400, all divided by 2 times 1. Okay, simplify that out, folks, using your calculator. Under the square root, you should get 1625. And dividing by 2. Here's a case, ladies and gentlemen, that I look to see, is it worth my while to simplify this expression like that radical exercise we did to put it in simplest form? And in this case, I noticed that I have an even out front and an odd down below. So there's no way I'm going to be able to cancel. So I'm not even going to bother trying to simplify that radical part. So I'm just going to leave it as it is. If my outside term here had been even, then I would have looked to, because I have even values that I could have canceled all along. But in this case, we're just going to go for the two options. So it's going to be negative 5 plus root 1625, all divided by 2. Or your second option, W equals negative 5 minus root 1625, all divided by 2. Plug these in your calculator, ladies and gentlemen. Okay, and this solution is W equals approximately 17.66 meters. And this one is approximately negative 22.66 meters. And taking a look, ladies and gentlemen, is it possible to have a negative width? No. So we are looking at this as our answer. So therefore, width is 17.66 meters. And ladies and gentlemen, how would I find the width? How would I find the length? Remember, length equals W plus 5. So it's going to be 17.66 plus 5, which equals 22.66 meters. Okay? So the width is 17.66 meters, and length is 22.66 meters. Now you may say, hey, Mrs. R, why didn't you include a nice diagram showing the maximum height and seeing if we could solve it that way? The reason I didn't, folks, is it just said the area equals 400. It didn't say the area maximizes to 400, okay? So that's the case where I didn't draw the diagram. All right, because it did not say maximum area. If it did a maximum area, then I would draw that nice parabola and show you that nice graph. All right, here's today's homework. Page 177, numbers 4, 5, 8, 9, 11, and give 12 and 13 a try. And again, come see me if you need any help. I apologize for that technical difficulty. That's why we have 2 videos for this lesson. I apologize. Hopefully this provides you a better understanding, though. Anyway, as always, come see me if you need any extra help, and have a great day.